Today is the 15th of August 2023, and would like to do look at probability again, but this time the use of sample space diagrams. Okay, sample space diagrams. Okay, now before I begin the lesson, thank you to everyone who has been watching our videos. Okay, please subscribe, share, like, and follow us depending on which platform you are watching from. So for instance, if you are watching from YouTube, please subscribe. Okay, you can also share and like. Okay, if you are watching from Rambo, you can follow us there. Okay, if you're on Facebook, please share. Okay, don't keep it to yourself. If you like the videos and they are helping you, share it with your friends, because there are chances they might find something in there that can help them get a better grade. Okay, thank you very much. I normally write in the comment section, please follow my notes/scripts. Okay, what I normally want to say is, for instance, this is 62. Okay, so if my pen is pointing here, I end up saying 60 instead of 62. Please follow the script and go by 62. For instance, 1 is a numerator and 6 is a denominator. So if I'm explaining something about the possible outcomes and you had numerator, no, it's not numerator, it's denominator. Okay, if you see something like 39 and it's on its own, then it's on its own. But if there is a percentage and I say a degrees, no, it will be what is on the script. So I'll very much appreciate it if you help me on that. Thank you very much. And then another thing is scammers. Okay, they are all over the place. Please don't fall for them. I wouldn't send you a friend request on Facebook, or because I don't know you. Okay, and the people I know, I will send them a friend request. Okay, but I won't send you a friend request and then go on your messenger asking you to donate money to a charity, an orphanage somewhere. Maybe it doesn't even exist. Okay, I won't send you account numbers, foreign numbers, to donate money so that they can send you off. All these are scammers. It's not me. I do not have a charity. I don't have an orphanage. Okay, I do not have a charity, and even if I want to donate to charity, I'll donate it out of what I have. Okay, I'm not asking anybody for money to watch my videos, so please don't fall for scammers. If you've not heard it from me, then it's not me. Don't follow it. Just delete it and report it, or just delete it and just ignore it. Okay, now recap. In our last lesson, we talked about probability. We done probability earlier, okay? But this last lesson, we recapped what we did in probability, and we saw some bases. Like we said that if you throw a dice, okay, the outcome will be a 1/6. Okay, so if you throw a die, you have 6 possible outcomes if it's only one die. Okay, and to get any of those numbers, the outcome is 1/6. So the probability of getting 1 is 1/6. The probability of getting a 2 is 1/6. That is if you throw only one die. Okay, if you throw a coin, your probability is half, because you can either get a head or a tail. You can't get both. Okay, so this is what we've been discussing in our last lesson. Okay, now I want to start this lesson today by introducing you to a two-way table, because we'll need it to use for our sample space diagram. Okay, so for instance, this is a two-way diagram here. Okay, you can pause here and have a quick look. Okay, so that's it, of an animal shelter. So this shelter, they have cats, dogs, hamster. The total is 300. Now, the green numbers, you had to find them. Okay, they have male and female cats, dogs, and hamsters. Okay, now the total. So you have the male. Okay, so in the male section they gave you 45, and then they gave you in the dog section the female is 36, and then they gave you 75 here. Okay, now they gave you the total of cats is 103, and the total of dogs is 75. So you know the total is in the whole shelter is 300. So you know the total number of dogs, and the total number of, the total number of cats, and the total number of dogs. So if you add them together and subtract from 300, you are left with 122 hamsters. Okay, that's why I wrote it in green, because you were not given this one. Okay, now you know that now you have 75 total dogs, but you've been given 36 female dogs. So if you subtract 36 from 75, then you are going to get 39 male dogs. So this column is also completed. Okay, now you know there are 45 male cats. So if you take 45 from 103, you have 58 female cats. Okay, so we've done this column, we've done this, that for the dogs, we've done for the cats, we've done for the dogs. Now we know that we have 122 hamsters, but we don't know how many males and female there are. But because we filled for the dogs and cats, we can use our knowledge there. Okay, so now In total, there are female 154 of the animals. Okay, we know that there are 58 dogs, cats, because we found them. We know there are 36 dogs. Okay, so now if we subtract 58 and 36 from 154, which we've been given, then we have 60 hamsters. Okay, we haven't been given this. Okay, now we know 122. Okay, because we found it using 103 and 75 dogs, 103 cats and 75 dogs. Okay, so we know that there are 122 hamsters. So if we subtract 60 female hamsters from 122 hamsters, then we are left with 62 male hamsters. So basically, we've done our table. Okay, I hope that is clear. Okay, this is called a two-way table. Okay, for an animal shelter. They might give you something like this in one of your papers, just to see if you can maneuver yourself around. They will give you some of the numbers and they'll ask you to find the missing numbers. Okay, so this is easy. Do not forget this. We'll use this sometime. Okay. Now today, as I said, we want to talk about the use of sample space diagrams, and it involves tables. Okay, some people don't really need it. If you become used to this under exam conditions, if they are asking you to do it, then you do it. But if not, you can quickly do it on the side of your exam paper and use it to solve the question. Okay, so here, to find the probability, you need to know all the possible outcomes. Okay, if you have to throw a coin, you know that it's either a head or a tail. So that you only have two possible outcomes. So you can either get a head, which is half, or a tail, which is half. But if you are throwing two coins, then you need to know the two possible outcomes. This one is easy because you can do it straight away. Okay, so if you throw two coins, you can either get four possible outcomes. This one, you can easily do it on top of your head without getting muddied. Okay, but what if you are supposed to throw a coin and a die or two dice? How are you going to figure out the possible outcomes? Well, if you've done it for a long time, you might know, but the use of sample space diagram, okay, helps you to answer the questions that will follow. Okay, so you can quickly do a sample space diagram by your question in pencil and then on your answer booklet, and then use it to solve the question systematically. Okay, now assuming you toss two coins, so that's coin 1 and coin 2, you can swap them around. So with coin 1, you can get a head or a tail outcome, and coin 2, you can get a head or a tail outcome. Okay, so now if you toss both of them together, you can either get a head and a head, okay, there, or a head and a tail there, or a tail and a head there, or a tail and a tail there. So the little things I've written under is you can get a head coin 1, head coin 2, okay, head coin 2, tail coin 1. Okay, let me do this properly so that you don't muddy up. Okay, let's do it in the same order. So head coin 2, head coin 1, head coin 2, tail coin 1, tail coin 2, head coin 1. Okay, and then tail coin 2, head coin 1. So straight away, if they ask you to find what is the probability of getting the 2 tails, then you know it's 1/4. So what's if they ask you what's the probability of getting 2 tails, because you can only get one possible outcome as there, then you know that it's one possible outcome out of all the 4 possible outcomes. Yesterday I gave you the formula for finding probability, so you can go and have a quick look. So this is the sample space diagram for tossing 2 coins. Okay, now if they give you a dice and a coin, okay, so now you have a dice and you have a coin. If you look at this, you have 12 possible outcomes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now if you've done this over and over again, you can also solve it. But if they make the question complicated, then you will be lost. So it's better you use the sample space diagram, draw it on the side and use it, because immediately you are able to do this, you can answer any question. So the die has 6 possible outcomes and the coin has 2 outcomes. Okay, so you can either get the first one, you can get a 1 on your die and a head because you are throwing both together, or you can get 1 on the die and a tail. You can get 2 on the dice and a head there, or 2 on the dice and a tail, that one. You can get 3 on the dice and a head, or 3 on the dice and a tail. You can get 4 on the dice and a head. You can get 4 on the dice and a tail on the coin. You can get 5 on the dice and head on the coin, 5 on the dice and the tail for the coin. You can get 6 on the dice, okay, and head on the tail, or 6 on the dice and tail for the coin. These are the 12 possible outcomes. So if they ask you what is the probability of getting a 6 and a head, it occurs only once. Okay, So your probability straight away is 1/12. Okay, so this is the sample space diagram for a dice and a coin. Now, if you have 2 dice, okay, now you have 2 dice. The first die has up to 6. The second die also has up to 6. Okay, so if you want to do the sample space diagram as I've shown you earlier, okay, here I've done it for you, but you can pause here, draw your own sample space diagram and write it, do it yourself. Okay, so you can get a 1 and a 1. Okay, what D2 means is dice 2, dice 1. You can swap them around. Okay, you can get 1 on the second die and 2. You can get 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, okay, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6, 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6, 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6, 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So these are the 36 possible outcomes that you get if you throw 2 dice. Okay, so if you can do this, then you are in a good spot in answering, assuming your question is about 2 dice, then you are in a good spot in answering the die question. Okay, so you know that there are 36 possible outcomes, which is your denominator answer. So here, if they ask you what is the probability of getting a 6 and a 6, it only occurs once on the table, so that will be 1/36. Okay, so if they ask you what is the probability of getting a score that is up to 4, so this is 1, 3 and 4, 3 on the second die, 1 on the first die, 2 and 2, and 1 and 3. They are asking you for a score, a total of 4. So you can see it on the table straight away. 1, 2, 3. So it will be 3 divided by 36, which is 1/12. Okay, so these are the uses. So immediately you can get the possible outcomes and put them on a sample space diagram. Then you are good to answer any question on a probability question. Okay, like this. So maybe the question might begin like, do a sample space diagram Or even if they don't ask you to do that, okay, if they ask you to do it, try and do it properly, systematically, so that you can score the full marks for the diagram, because this is easy, very easy to do. Okay, so even if it's a mark or two, you want to get that. Okay, so don't muddy yourself and then you end up losing those marks. Okay, and then now you are in a very, very good spot to see clearly, to answer any of the question, how they might twist it for you to get the marks. So you can also get a full marks on a probability question. Okay, now after saying all that, we want to look complete today by looking at what are mutually exclusive events. Okay, I mentioned it in one of our earlier videos, but I didn't explain it that much. So after what I've told you today, okay, mutually exclusive events are events that will not happen at the same time. Okay, for example, if you toss a coin, you can either get a head or tail. You can't get both happening at the same time. Okay, you've seen it in the football match. When they start, they toss a coin. You don't get two outcomes the same time. That is a mutually exclusive event. Okay, so you either get a head or a tail, not both. Okay, if you toss a coin and a die, as you have seen in the sample space diagram, you can only get one possible outcome at a time, no more than one. Okay, so you can get one outcome out of the 12 possible outcomes. Okay, similarly, if you toss two dice, you can only get one possible outcomes out of the whole of the 36 outcomes that we've done in our table. You can't get three. So you can either get a 1 and a 6, a 2 and a 6, if you toss two diagrams. But you can't get at the same time a 2 and a 2 and a 4 and a 2. You can't do that. Those events are called mutually exclusive events. Okay, so when you can only get one event happening at the same time, then it is a mutually exclusive event. Most of the questions in probability, they will tell you it's a mutually exclusive event. This is what it means. Only one can happen at the same time. So that's why you need your sample space diagram to solve that question. So even if they're not asking you to do it, for instance, if you have two dice, to look at it, you can quickly draw it on the side, not with a ruler as I have done it, but you can draw it, make a diagram with your hand. Okay, put in die 1, die 6, and write fill all the 36 possible outcomes and use it to solve the question. Okay, So you cannot have all the 36 possible the outcomes. You can only always have one outcome. Okay. So what have we been looking at today? We looked at, we recap on probability, and then we look at the two-way table from the animal shelter. This is okay, and I helped you fill out the empty spots which I've put in green. I explained that to you, okay, and then I've shown you the use of sample space diagram, okay, and then we've talked about mutually exclusive events. Okay, so thank you very much for watching today's lesson, and I'll see you in the next